number of divisors. Thus, combining this with the number of the solutions belonging to the first class previously obtained, we get the summation with the upper limit of square root of x with the lower limit of n equals to 1 multiplied by x over n plus the summation with the upper limit of square root of x with the lower limit of m equals to 1 multiplied by x over m minus and multiplied with the square root of x raised to 2. As the number of all the solutions of inequalities in natural numbers m, n, the value of the function tx, we have the summation of with the upper limit of square root of x, the lower limit of m equals to 1, multiplied by x over m is equal to with the summation of the upper limit of x square root of x with the lower limit of n equals to 1 multiplied by x over n, because both the sums are abbreviated forms of the sum x over 1 plus x over 2 plus dot 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 plus x over square root of x. Therefore, we may write the equation into t of x is equals to 2 with the summation of the upper limit of square root of x with the lower limit of n equals to 1 multiplied by x over n minus with the and multiply with the square root of x raised to 2. Example, t of 100 equals to 2 with the summation with the upper limit of 10 with the lower limit of n minus 1 multiplied by 100 over n minus 10 squared. So it becomes like this, equals 2 multiplied by 100 plus 50 plus 33 plus 25 plus 20 plus 16 plus 14 plus 12 plus 11 plus 10 minus 100 is equals to 2.291 minus 100 is equals to 482. Similarly, by an easy calculation, we find t of 200 is equals to 1098, t of 500 is equals to 3190, t of 1000 is equals to 7069. Slightly longer calculations lead us to the values of t 5000 is equals to 43,376, or t of 10,000 is equals to 93,668. From formula, an approximate formula of the average value of the function d of n is easily obtainable. If on the right hand side of formula we replace x over k simply by x over k, then the error in each of the summands in less than 1, and consequently in the whole sum it is less than the number of the summands, or less than x. Therefore, as an approximate value of t of x, we have the summation with the upper limit of x and the lower limit of n equals to 1, x over n. The error of the approximation being less than x. For natural values of x equals to k, we then have d times 1 plus d times 2 plus dot 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 plus d times k over k is equals to 1 over 1 plus 1 over 2 plus dot 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 plus 1 over k. Sums d times 1 plus d times 2 plus dot 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 plus d of n. The error of the approximation being less than 1, since the right hand side of 14 increases to infinity with k of 1, the ratio of the left hand side to the right hand side of 14 tends to 1 when k tends to infinity. As is known from analysis, for the approximate value of the sum 1 over 1 plus 1 half plus dot 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 plus 1 over k, we may take the number log k, the error being less than for k greater than 1. Consequently, log k is an approximate value of the left hand side of 14. As one proves in analysis, the difference between 1 over 1 plus 1 half plus dot 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 plus 1 over k minus log k tends to the finite limit called Euler's constant. c is equals to 0.57721566. We do not know whether it is an irrational number. On the basis of this and formula, the expression x log x plus multiplied by 2c minus 1 x has been found, which approximates to t of x, which an error less than a finite multiple of the square root of x. G. Voronoi proved that the error is not greater than a finite multiple of the square root of x log x raised to 3. Later, other authors found more precise evaluations of this error by Yin Wen Lin. Numbers d of n as coefficients of expansions. The function d of n appears in analysis as a coefficient of expansion in infinite series. For instance, consider the series convergent for x is less than 1. We have the summation of with the upper limit of infinite with the lower limit of k is equals to 1. X raised to k over 1 minus x raised to k is equals to x over 1 minus k plus x squared over 1 minus x squared plus x3 over 1 minus x cubed plus dot dot dot. Known under the name of Lambert series, expanding each of its terms into the geometrical progression, we have x raised to k over 1 minus x raised to k is equals to x raised to k plus x squared k plus x cubed k plus dot dot dot. We obtain the double sum by the summation of with the upper limit of infinite with the lower limit of k equals to 1, and the summation of with the upper limit of infinite and with the lower limit of 1 is equals to 1 x k 1, in which for every natural number n, the power x raised to n appears as many times as there are solutions of the equations kl equals to n, and natural numbers k and l d of n times. Hence, for x is less than 1, we have with the summations with the upper limit of infinite with the lower limit of k is equals to 1 multiplied by k raised to k over 1 minus k raised minus x raised to k is equal to with the summation with the upper limit of infinite with the lower limit of n equals to 1 multiplied by d of n x raised to n. We see that the function d of n is a coefficient at x raised to n in the expansion of Lambert series in a power series.